Good morning, good afternoon, good evening. Wherever you are watching this video, let me welcome you all to our channel Future Endeavors. Okay, so in the previous class, we have already discussed about the electrovalent or ionic bond. Then we have discussed about the covalent bond, and through electron dot structure, we have shown the formation of the molecules of various elements as well as various compounds. Okay, so in today's class we are going to move forward. We are going to discuss the third kind of bond, which is called coordinate bond. Coordinate bond, or it's also called the dative bond. DATIVE, dative bond. Okay, so what is special about this bond? What is different in this bond from covalent or electrovalent bond? Okay, see, in electrovalent or ionic bond, you have seen that electrons are being transferred from metallic atom to non-metallic atom. As a result, metallic atom forms positive ion, non-metallic atoms form negative ion, and the electrostatic force of attraction between the two kind of ions results in the formation of ionic bond. Likewise, in covalent bond, we have seen that electron pairs are being shared between two atoms. Mainly those are always non-metallic in nature, two atoms, and due to this sharing, an interactive force develops, and that interactive force holds on the atoms together in a molecule, resulting in the formation of covalent bond. So third kind of bond is coordinate bond or dative bond. Now see, this can also be considered to be a type of covalent bond, rather similar to covalent bond, something similar to covalent bond. How similar? As in covalent bond, you have seen electron pairs are being shared. Okay, here in coordinate or dative bond, the shared pair of electron, okay, the shared pair of electron or electrons, you can also say electrons, are totally contributed by only one atom. Okay, so in covalent bond, you have seen that the shared pair of electrons were being contributed by the two atoms, one electron, one atom. Okay, but here in case of coordinate or dative bond, the shared pair of electrons are totally contributed by one single atom only. So this is the main difference. So shall we say an example? Yes, definitely. So let us consider how the coordinate bond is being formed. Let us take one example. See, while discussing the ionic or covalent bonds, I think I have discussed in one of the formations, showing one of the formations about lone pair of electrons. I think I have discussed it. So lone pair of electrons, if you remember, and I think I have discussed or I have mentioned the lone pair of electron in case of formation of ammonia molecule. So I am just repeating that structure once again. Nitrogen, it has 5 atoms, 5 electrons in the outermost shell. Okay, and there are 3 hydrogen atoms. This is one hydrogen atom, okay, forming a bond. This is one hydrogen atom forming a bond, and this is one hydrogen atom forming a bond. Now these 3 hydrogen atoms, what they do, they each share one pair of electrons with nitrogen atom, okay, like this, and the nitrogen atom has itself 2 electrons more which are free. They are not involved in any kind of bond, and we have mentioned that this kind of free electrons, not actually free electrons, this kind of electrons which are not participating in any bond, they are present only in the outer shell of the atom, are regarded as the lone pair of electrons. Now what happens? Lone pair of electrons. So nitrogen atom will always try to utilize this lone pair of electrons, but how? See, this is a totally neutral molecule, because if you consider all the 4 atoms, one nitrogen and other 3 hydrogen atoms, what happens? If you can't count the total number of electrons and protons, they have equal number of electrons and protons. Okay, so this is neutral molecule. Now say if a hydrogen ion H plus comes near this ammonia molecule, what happens? This hydrogen ion, what happens? This hydrogen ion has no electron in its outermost shell. Now the nitrogen atom suddenly, when sees this hydrogen atom, it gives away its lone pair of electron to the hydrogen ion, because hydrogen ion does not have any one electron, so it will require two electrons to acquire the configuration of the helium. So this nitrogen atom will donate its lone pair of electron to this hydrogen ion rather. And see, when this hydrogen, in this way the hydrogen ion comes and gets binded with the ammonia molecule. Is it clear? Comes and gets binded with this ammonia molecule. When this nitrogen atom binds with the hydrogen ion binds with the ammonia molecule, what happens? The overall combination of this 4 plus 1, 5 atoms, okay, does not remain neutral any further. Why? Because this is because if we count all the protons and neutrons of this 1, 2, 3, 4 and then 5 atoms together, you will see that it will have one less electron. Okay, it has one more proton, rather I should say that way, it has one more proton than the number of electrons present. So ultimately what happens? Ultimately this structure seems something like this. So the hydrogen ion combines, and so the structure becomes something like this, NH4, because there are already 3 hydrogen atoms, another hydrogen atom comes in and it joins with the ammonia molecule, and overall this ammonia molecule with the hydrogen ion will have one excess positive charge. Okay, so now this behaves as a radical. We have already discussed what a radical is. So this behaves as a radical with a positive charge. So the formation of this kind of radical is due to the presence of the coordinate or dative bond. So I think the concept is clear. Okay, so in this way a coordinate or dative bond is being formed. Okay, you can take another example. Definitely yes. So if we consider, you have learnt of hydronium ion. Okay, have you learnt of hydronium ion? H3O plus. Okay, H3O plus. What is that ion? Okay, let us see. So if we see the, first of all, let us see the structure of water molecule. By now you have almost I think you have understood the concept of formation of water molecule. If not, please watch the previous videos, it will be clear. So water molecule, oxygen atom, okay, oxygen atom, it forms bond with 2 hydrogen atoms. Okay, so this is one hydrogen atom and say this is one hydrogen atom. Okay, 2 hydrogen atoms. Okay, so it shares, here is one pair of share, here is one shared pair of electron. So oxygen has 6 electrons in its outermost shell. It gets 2 electrons from the 2 hydrogen atoms. So there should be another 4 electrons present here. 1, 2, 3, and then here 4, 5, 6, 7, 8. Okay, fine. So oxygen has 2 lone pair of electrons. Okay. Now when again if we consider, if a hydrogen ion H1 plus ion comes near this structure, what happens? The oxygen atom gives away its one lone pair of electron. Okay, it gives away its one lone pair of electron and it binds the hydrogen ion with itself. As a result, what happens? So structure becomes something like this. The structure becomes H3O and with a positive charge. Why H3O? Because now 3 hydrogen ions come together. So H3O 1 plus is the ion. So this is also kind of radical. Okay, so in this way the coordinate or dative bond actually helps in the formation of structures like this. Okay, so with that we come to the end of this class, and I think the basic concepts of bonding has been cleared. Please do watch the videos carefully. If you have any problem, do mention it in the comment box. We'll be happy to solve the problem. Okay, thank you. Goodbye.